In this lesson, I'll show you how to use the laws of exponents to simplify an expression. The first question asks us to simplify using the laws of exponents the expression x to the power of p minus 1 times y to the power of 2 all over x to the power of p plus 4 y to the power of 1 minus p. To do this, we'll need to use the quotient rule. The quotient rule will be used for the x's and for the y's. Let's start with the x. We have x to the power of p minus 1 over x to the power of p plus 4. To use the quotient rule here, I'll have to subtract p minus 1 with p plus 4. So I have p minus 1 minus this expression, p plus 4. Students often forget to put the brackets around the bottom exponent. And if you do that, then you'll get the wrong answer. So we have p minus 1, and I'll distribute this negative to both of these terms, where I have minus p minus 4. This p and this p cancel out, leaving us with minus 1 minus 4, which is minus 5. So we have x to the power of minus 5. Next, we'll move on to the y term. We have y to the power of 2 over y to the power of 1 minus p. Once again, according to the quotient rule, we'll be subtracting the exponents 2 minus 1 minus p. Notice the brackets around the exponents. Here we have 2 minus 1 plus p. This minus 1 influences the signs of the terms that are inside the brackets. This gives us 1 plus p. Therefore, we have y to the power of 1 plus p. Now I'll multiply x to the power of negative 5 with y to the power of 1 plus p. And we get this expression, but this expression has negative exponents. Many teachers will not like the fact that you have negative exponents. So, to get rid of negative exponents, we use the negative exponent rule of the exponent laws. This can be changed into x to the power of positive 5 instead of negative 5, just as long as you reciprocate it and put it at the bottom. And vice versa, if that negative exponent were already in the denominator, you would put it at the top. So this represents the answer to question A. In question B, we have a slightly more complicated expression. We have these two factors being divided and then this one being multiplied on the outside. The first thing that I would do to approach this is change this into multiplication and flip this fraction. Because according to the order of operation, we have to do what's inside the brackets first. So that's why I'm focusing on these two factors within. If I do that, I end up with 5a to the power of 3 over 25b to the power of 3, a to the power of m minus 1, and this becomes a to the power of m plus n over a to the power of n plus 1. And don't forget that this factor is being multiplied to this factor, so I'll put a dot to show that. And we have b to the power of n over a to the power of m minus 1 also being multiplied. So let's go ahead and multiply everything that's in the numerator position. Keep in mind that this is one complete term. We don't have separate terms here, so we can multiply just like how we would multiply fractions. 5a to the power of 3 times a to the power of m plus n times b to the power of n. This gives us 5a to the power of 3 plus m plus n. I'm using the product rule for this, add it to this, and b to the power of n. All over, and now I'll multiply all of the denominators. This is a little more complicated because we have all these a's with different exponents. 25b to the power of 3. And to give you the answer for these, I'll do my work on the side. We have a to the power of m minus 1 times a with different exponents. So we'll be using the product rule by adding this, this, and this, plus n plus 1 plus m minus 1. A to the power of m plus m is 2m, minus 1 plus 1, that goes away. We still have this minus 1 though, and we still have this n. So plus n minus 1. I'll put a to the power of 2m plus n minus 1 at the bottom. Now a lot of students will stop at this point, but you shouldn't. There's still more to do. You see this a term and this a term? They can be simplified further. by using the quotient rule. The quotient rule tells us that if the bases are the same, then we can subtract the exponents. So let's do our work here again. 3 plus m plus n minus, and let's see if you'll remember this, bracket 2m plus n minus 1. I'm putting emphasis on that because students often make this error. This negative will multiply to each of the terms within the brackets, giving us 3 plus m plus n minus 2m minus n plus 1. Let's combine like terms. 3 will be combined with 1. M will be combined with negative 2m. And n will be combined with negative n, giving us 3 plus 1 is 4. M plus negative 2m gives us negative m. Positive n minus n gives us 0. This means that our answer will be 5 b to the power of n, whatever a was, its exponent, a to the power of 4 minus m, over 25 b to the power of 3. You've probably noticed this already. 5 divided by 25 gives us 5 underneath and 1 over here, leaving us with the expression b to the power of n, a to the power of 4 over b to the power of 3, a to the power of positive m, because this cannot be left at the top since it's a negative exponent. Here is your final answer. Finally, in question C, this is the most complicated one. This requires some math intuition to figure this one out. In fact, I would rate this one the hardest out of the three. What you want to do is change this expression somehow so that it can be cancelled out with the expression at the bottom. What I'll do is change this part of the numerator, p to the power of 4m, into p to the power of 2m to the power of 2. And also change that into q to the power of n to the power of 2. And by doing that, you have created a difference of squares. And you can factor a difference of squares. Now here's an example of a difference of squares. A squared minus b squared. This is square rootable. You can find a perfect square for that term. And this is a perfect square, b to the power of 2, which is b. Also, these two squares are being subtracted. Because of that, this expression, this binomial, can be factored as a minus b, a plus b. And if you don't believe me, expand this and you should end up with this expression. The reason why this is important for us is because this is a perfect square and this is a perfect square, and they're being subtracted. So I can use this logic to break this down into two binomials. We have p2m minus qn and p2m plus qn over p to the power of 2m plus q to the power of n. As a result, this bottom binomial and this factor will cancel out, leaving us with the final expression. That's your answer, what's highlighted, and only what's highlighted. And there you have it. 3 more examples on how to use the laws of exponents to simplify any expression. And if you still have a hard time with this, go back to part 1 and part 2, study those, and by studying those, you should be able to figure these out faster.